Welcome to Summarize Science. As drones become more common, our cities are preparing for the low-altitude economy. This includes fast delivery services, infrastructure inspections, and even urban air travel. However, a major challenge has emerged, distinguishing between a flying drone and a common bird. Currently, radar systems can be easily confused, leading to false alarms that disrupt security. Researchers have proposed a new scheme called AirGuard to solve this identity crisis. They utilized integrated sensing and communications, which is a core technology for future 6G networks. This allows base stations to both communicate with devices and sense the environment like a high-tech radar. To make this work, they modeled how signals bounce off moving objects in the sky. These signals are sensitive to tiny movements, like the rotation of a drone's propeller. By analyzing these echoes, the system can gather detailed information about a target's speed and position. The researchers started by creating highly detailed 3D models of various drone types. They converted these models into point clouds to simulate how a radar would see the drone. This allowed them to calculate exactly how propeller rotation affects the returned signal. They also created detailed 3D models for different types of birds. By simulating the flapping of wings, they identified the unique signal signatures that birds leave behind. Comparing mechanical rotation to biological flapping is key to the system's success. One of the primary tools used is the microdoppler spectrum. Think of this as a motion fingerprint that shows how parts of a target move over time. Drones produce distinct, high-frequency patterns because of their fast-spinning rotors. They also looked at the high-resolution range profile, which examines physical structure. This feature reflects the target's size and shape along the line of sight. Since birds and drones have different shapes, this provides another layer of identification. All of this data was fed into a specialized artificial intelligence network. This network combines motion fingerprints and structural data to make a final decision. It uses convolutional layers, similar to how modern face recognition software works. To train the AI, they used data from 15 types of targets, including drones and birds. This diverse dataset ensures the system can recognize everything from a sparrow to a delivery drone. The results were impressive, with the system achieving a recognition accuracy of over 98%. Even in noisy environments, the AI was able to tell mechanical from biological targets. To recap, this research shows that 6G technology and deep learning can clear up sky-high confusion. This means fewer false alarms for security and a safer environment for everyone. In the future, this could allow thousands of drones to operate safely without interfering with wildlife. Thanks for watching Summarized Science, where complex research is made easy to understand.